Welcome to the session. I hope you're having a good conference so far. I'm Suganya Baskaran, and this is my colleague Divesh Goyal. And today, we'll see how you can build apps using ArcGIS Runtime SDKs for iOS and macOS. Before we begin, how many of you are iOS developers? Okay, about half. Have any of you worked with the version 100 of Runtime SDKs? Okay, not bad. Okay, this session is aimed at anyone interested in taking ArcGIS platform to iOS and Mac. And we hope to give you a good starting point, whether you are a developer or any other stakeholder. Here's our agenda. We'll start off with what ArcGIS Runtime is, introduce the next generation of Runtime SDKs, and show available resources. Then we'll dive right into the core components of the SDK. Specifically, we will look at 4 sections in detail, depending on how your users might want to interact with their ArcGIS content. First, we'll see how you can display map content and build an app from scratch. Next, we'll talk about searching for content in your ArcGIS services, followed by a section on analysis. Then, we'll talk about editing content, and finally conclude by talking about some licensing. Okay, let's get started. What is ArcGIS Runtime? Runtime consists of a conceptual model and a common set of core GIS functionalities that have been implemented using C++ and a new common C API. Different SDKs that are native to a number of different platforms have been built using runtime as their foundation. This really gives a win-win for all of us. With the platform independence of C++ and C, we are able to effectively build and ship many great products, all the while harnessing the GPU acceleration capabilities of the device. For you as a developer or project stakeholder, this brings powerful GIS capabilities to your native apps, while also maintaining the look and feel of your target platform. Runtime facilitates easy multi-platform development with specific products for it. And the APIs are intuitive to learn once you're familiar with one of them because they share a common design. As many of you know, we released the next generation of Runtime SDKs, version 100, past November. This was made possible by this new runtime architecture. With the C++ runtime layer we already had, we have introduced a new common C API layer. While the mapping and GIS services are still provided by the C++ core, most of the SDK functionalities have been implemented at the C API. This has enabled us to provide you with a consistent design, API, and behavior for all these different SDKs that wrap the C API. It has also enabled us to scale up our developmental efforts and have synchronized release of functionality. Next, let's talk about the SDKs. The iOS SDK supports iPod Touch, iPhone, and iPad devices, and the macOS supports MacBooks and iMacs. The two platforms are very much similar in the way in which you build them with respect to programming language, design patterns, and development tools. So if you're familiar with one of them, your transition to the other should be simpler. If not, you learn one, and you can build apps for both. iOS SDK requires that you have a minimum iOS version of 9, and the macOS, it's 10.11, that's El Capitan. Xcode is the IDE that you use to design and develop your iOS and Mac apps, and the programming languages you can use are Objective-C and Swift. Next, let's take a look at where you can get more information about the SDKs. It's the ArcGIS developers website. You may find yourself referring to this site frequently as you build your apps. Let's look at it now. So this is the ArcGIS developers website. And this section here would be your gateway for the different web, runtime, and scripting APIs. Before we go into the iOS section, I'd like to quickly point out the dev labs that we introduced last week. The aim of Dev Labs is to provide you with simple step-by-step tutorial in the data, design, and developmental phases of your app. The Develop tab here has labs for different web and runtime SDKs, including iOS and macOS. Let's go to iOS. There are a few labs here. The first one here is to really set up a basic project and display a map. And each lab has some overview, the exact steps that you need to do, and a challenge towards the end. Do check this out. Now, back to the developers page. Let's go into the iOS SDKs page. You can download and install the SDK from here, or you can use CocoaPods. While the DevLabs helps you with a step-by-step tutorial, the guide section here provides you with a number of conceptual articles, both about the SDK and the ArcGIS platform. Let's take one of the examples here, displaying a map. This shows how you can open a map, how you can, your map can come from a portal item or a mobile map package, etc. And the code for all of these articles are available in both Objective-C and Swift. Going back to the table of contents here, there are other categories that help you work with 3D, display information, searching. Let's look at edit features. This has a good overview of editing and talks at high level about online, offline workflows, etc. So that's the guide section. The developer's website also has an API ref doc. You can search for any class. And this class, for instance, has some information about it, and it has description for its properties and methods. Next, I'd like to talk about the samples. You get access to a plethora of samples using the Runtime SDKs. In fact, we have released a samples app that you can download from App Store. The samples are also hosted in GitHub. Let's take a look at that. As you see, there are different categories, and each category has a number of samples under them. Let's take a sample, for example, create and save a map. It has some basic information on how to use the sample, some useful screenshots, and also the expected behavior of the sample. Similarly, for macOS also, the samples are hosted in Esri's GitHub page. Coming back to the developers page, finally, I'd like to point you to our user forum, GeoNet. You can post your questions and issues here and get them answered by fellow developers or Esri staff. So that's the developers website. You get access to DevLabs, guide docs, API ref docs, samples, and user forums. It's extremely useful, and I urge you to check it out.
Quick question.
Yeah.
Is it mostly Swift 3? The Swift you have, is it Swift 2 or 3?
I think we've upgraded it to Swift 3.
We've upgraded all the samples to use Swift 3.
Great.
The guide documentation still uses Swift 2.3. We're in the process of upgrading that.
Okay, with that, I'll hand it over to Divesh now to get us started with the core capabilities of the SDK.
Thanks, Suganya. Let's go ahead and talk about our first section, which is displaying content. Now, this is obviously probably the most important section where everybody wants to display some geographic content in their apps. And you'll see that it's actually quite easy to do. So when you start off, you have choice of what type of content you want to show. And generally, there's two broad categories. You're either displaying two-dimensional maps or three-dimensional scenes. And the ArcGIS platform supports both of them. The Mac supports both 2D and 3D, but iOS at this release only supports 2D. We hope to add support for 3D in the next release, which is in a few months. So it's really close. We actually have a beta of it out there in the current release that you can play with and see how it works. But we still have a little more work to do. Regardless of the type of content you choose, the structure and organization of this data is basically the same. You have operational layers that are displayed on top, and these layers really are unique to your map or your application and are of particular interest to the user, because many times this is the layer that enables those user workflows. Examples of an operational layer may be a utility network for an asset management application, or the burn area for a firefighting app. Below the operational layers is your base map, and the base map just provides some geographic context for all the layers on top. So it's some common data like roads or administrative boundaries or satellite imagery, and it doesn't change much. And it's usually common between a lot of maps and applications. Now, if you're using 3D scenes, then you may also have another type of content, which is called a surface. And this surface sits below the base map, and the base map is draped on top of it to give it some depth, so you can appreciate the topography of the geographic area that you're looking at. Now, that's a structure of a map or a scene, but really what it's composed of is layers. Layers in the base map and layers in the operational layers. And we have a number of different layer types in runtime for you to choose from, depending on what the data is and what your application needs to do with it. So for example, we provide tile layers that fetch pre-cached tiles from the service and then assemble those tiles on screen. And these layers are really good for displaying static data very quickly, because the tiles are already pre-cached and it's just assembling them on screen. And we have two layers for this, the ArcGIS tile layer and the vector tile layer, because there are two tile formats. One is this raster or pixel-based tiles, which is really good for things like satellite imagery. And then we have vector tiles, which are really good for vector data that can be restyled or customized. But they both work the same way. And these layers can work with services that provide those tiles, or they can work with local content like tile packages that have those, the same data. Well, sometimes, even if your data is not changing frequently, your clients may want to customize the display of that data. So turn off or on some layers. With tiles, you really cannot do that because all of that data is already burnt in. That's where the next layer, the map image layer, comes into play. Is it can allow you, it still generates an image from the service, but that image is generated on demand. So the client can specify what layers they want or what symbology they want to use. And this is really good if you have vast amounts of data that you don't want to bring to the client. You can just bring an image of it, which is really small and efficient. Offline, definitely, we understand you need to take your base maps offline. So those tile layers are available in an offline mode with either vector tile package or tile package. Map image layers, on the other hand, can't work offline because they rely on the server to do the crunching and give you an image.
So the vector tile layer, it is baked into the model that you cannot change the visibility of certain layers inside the vector tile layer, even though it is possible.
Correct. At this point, we don't provide those capabilities. What we're going to allow you to do is customize the symbology of those layers. And that is in the future. We don't allow that today with local vector tiles. We allow that for online vector tiles, where you can publish a style file and then in that style file you can then choose to say certain colors are transparent, and that way you turn off the layers. But no real way of, because it doesn't keep a categorization of layers. It just knows this is the data and this is the symbols I need to render it with. Moving on, there's a feature layer that the runtime provides, and this works different from the tile and map image layer, where the actual features are brought onto the device, into the application. They're held in the application by an object that we call a feature table, and this table allows you to do CRUD operations on it, like querying, creating, deleting, things like that. And this table works hand in hand with a layer, then that's responsible for visualizing those features on the map. So this is typically what you will use with your operation layers that you want to query or edit. And again, that table could contain data that's come from a service, like a map service or a feature service, or it could contain data that's coming from a local geodatabase on disk. So it can work in both online and offline modes, depending on what your application needs to do with it. And then we have introduced this raster layers also, which are currently in beta on iOS, but they're available in final form on Mac. And we'll be releasing them for final in the next version of the iOS SDK. And they're really good for pixel-based data, sort of like elevations or temperature, where you can apply raster functions on the fly to sort of do analysis and generate new products. And we support a number of different raster formats, like DTEDs, mosaic datasets, geotiffs, PNGs. And these raster files can be sitting locally on the device, so it's really efficient in displaying them. In the coming release, we'll be adding support for rasters coming through image services. So those are all the different types of layers that you have in your maps and scenes, but your maps and scenes can live in a variety of different places. For instance, they might live on the portal as web maps or web scenes. We've now made it possible for you to take the whole map offline using mobile map packages. And sometimes you may not be using a pre-authored map either in the portal or in the package. You may just create the map programmatically by mashing up a number of different layers in your application. That's perfectly fine as well. So all of that was about the map and scene, which constitutes the model component in an MVC architecture. So if you want to display those data sources on your device, you need to use something from the view component of that architecture. And for that, we provide things like a map view and a scene view. So a map view works with a map, a scene view works with a scene, and that's the way you can take the 2D and 3D content and create 2D and 3D visualization. And not only does it display it on screen, but it also handles all the user interaction with it in response to gestures. So users can pinch to zoom, rotate, use the keyboard, all of that. And these components extend the platform view components, like UI view on iOS and NS view on Mac. So you can treat them like any other view components, like a button or a slider that the platform provides. You can add them to storyboards. You can use auto layout, things like that. So it just works like any other view that you're used to using in your applications. Now, new with the version 100 is that the map view and scene view also provide this concept of graphic overlays, where you can add content on top of the map and scene. In the past, we used to provide graphics layers that could be interleaved with your content, but now we've changed that paradigm to make sure that the graphics overlays always stay on top. And this makes it really easy for if you want to like switch out your map, you don't lose your graphics. You don't have to do anything special as a developer to keep your graphics on top. They'll stay with the map view or the scene view, and the map and scene could change.
So what is the difference between an overlay and a layer? So overlay always stays on top of the
map and the scene.
The base map.
On top of the whole map. The operational layers, the base map, the surface, on top of the whole map or the whole scene.
Okay. But an overlay can still contain multiple geometries.
Yes, you can have more than one overlays, and each overlay can contain more than one type of geometry. We typically ask you to put one type of geometry in an overlay, so you can use a renderer with an overlay to symbolize it, and a renderer can only work with one type of geometry at a time. But if you're just assigning symbols directly to the graphics, you can add different types of geometries to the same overlay. That's okay. And then we provide conveniences on the map view and geo view in terms of the identify operations, where you could pass in a map point or a 3D point, and it'll tell you all the features and graphics at that location. So that makes it really easy for you to implement identified type of functionality. Changing the viewpoint of the geo view is very easy. We allow you to change the viewpoint based on extent, center and scale. And if you're using 3D content, you can use a camera where you can specify heading, altitude, pitch, and roll. So with that, let me go ahead and jump into a quick demo. And what I have here is a playground. Have any of you used playgrounds before? Some of you have, yeah. So those you who haven't, playgrounds really this live coding environment that Apple provides. It's following the REPL model where it's a read, evaluate, print loop. As you type code, it can show you the results of that code. And what I've done in the playground is just created a map view. And in this case, I'm creating it programmatically. I'm not using storyboards because that's not supported in Playground yet. I'm giving it a frame, saying it needs to be 350 by 350. And I create a map object. I set a base map on it. This time I'm using imagery with labels. And I assign that map to the map view. And that's it. And then I just create a location which is centered in Palm Springs using this point geometry. And I set the viewpoint of the map view by passing in that location as a center and telling it to zoom to a scale of 10,000. So if I go ahead and just hit play, and it's running. Sometimes Playground takes a while if you leave it open for long.
So is this code available somewhere?
Yes, we have a document that shows how you can use playgrounds, and then we have some code snippets. What you should have seen was the map view. You can see it's executing, but for some reason the map view isn't showing up.
Playground's only for iOS?
No. You could, yeah. Let me go and kill this and start up Xcode again. And I think we might see something. There we go. So Playground is a great place to experiment with code, including the runtime, where you don't have to build an application. You could just write a bunch of code. Now, the runtime uses a lot of asynchronous methods behind the scene. So what is important is that you need to set your Playground to say it needs indefinite execution, because the map view needs to fetch, content, display it, animate, and your Playground would finish before it's ready to display. So that's an example of using maps. And I can actually make one really small change. Instead of creating my map and setting base map and setting up the contents in code, I can go ahead and change it to use a web map. And if I go ahead and, did I quit that? If I go ahead and switch to my browser, I have this web map. And I'll go ahead and open it up again because I quit it by mistake. I'll go ahead and paste in the URL of that web map. Save and play. You'll see this time I get a completely different map, and this one has some feature layers on top showing some points of interest in Palm Springs. So that was just a simple change to use an existing map on a portal. So that is about working with playgrounds and maps, and I just want to show you another application really quickly that's built for the Mac. And you'll see I have a window in which I've added a scene view, and I'm using auto layout and interface builder to set the scene view. when I add the scene, when I add a view to this UI, I change its class to be the scene view. That's how it knows it's a scene view. And in the app delegate, I have an outlet to that scene view, and I create a scene, just set some base map on it, and add an elevation source to my base service so that it's draped nicely. Base map is draped nicely on it. If I go ahead and run this, here, that's a Swift thing. It's trying to unwrap the URL because the URL constructor can sometimes fail, not give you a URL if your URL is not formed correctly. So when you put a bang at the end of it, it'll unwrap it and make, and it could, if my URL was bad, that could crash. But since I know I'm using the right URL, I've taken a shortcut and just said unwrap it. So if I go ahead and, so there's my scene that's working on a Mac. If I go ahead and zoom in a little bit, and then use my keyboard and option key and hold down and drag, you can see I'm starting to get a sense of the elevation. So that's just a really quick demo of how you can easily display maps and scenes in your application. Now I just want to point you to a few other sessions that will touch upon and actually take what I said today and dive into it a little deeper, and that's working with maps online and offline. It's a little later in the day today. Building 3D applications on Friday, just talks about all the types of 3D data you can use in symbology. And then if you want to know more about rasters, we have a session on Thursday that talks about using the raster APIs in runtime. So that was about map view and scene view. Now the views also have some other capabilities, something that we call accessories that you can use, the really convenient things. For instance, you can put a grid on top of your map or scene content that shows lines of latitude and longitude, so your users have a sense of what they're looking at. We support many different formats like MGRS, USNG, UTM. The view has a magnifier. You can tap and hold, and it'll blow up the contents under the finger. It's got a sketch editor that allows you to interactively sketch on the map and create geometries or modify existing geometries. You can change the background of the views, so where you have holes in your data and you're seeing below the map or the scene, you can change the color of the background so it matches the base map a little better. You can show call out on top if you want to call the user's attention to a specific feature or location. And we provide a location display that shows the device location on the map and has different modes depending on if you want to use the compass sensor to orient the map or if you're in navigation mode. And all of those can be seen easily using the sample viewer apps that we've built. So to give you an example, here's so this is the sample viewer. It's got all these categories of samples. You can go ahead and pick one of the categories, say sketch on the map, and then if I start tapping, you can see I can create a line. And I can even bring up the magnifier, move the vertex, and I can undo and redo, and create polygons. So all of this is using the map view sketch editor. And the app even allows me to look at the code. So if I want to show you the code that was important for that, it's basically this geometry value change function where every time the user picks a new type of geometry, we start the sketch editor with the right type of creation mode. And then it handles all the user interaction. You can change symbology and things like that. We give you those options. But that's an example. Show call out. If you just tap on the map, it'll show a call out with the location that you tapped on and things like that. So I encourage you to explore this app and look at all the samples we have available. The source code is on GitHub. It's linked to from our developers page. Yeah, Scenes is on there, so it's in beta. It works, but we haven't done anything extensive with it, like adding scene layers and things like that. Yeah. Cool. We're back to Suganya.
Okay. Okay. Next, let's look at searching for content using iOS SDK. Searching could mean different things depending on the nature of your app. Your users could be searching for places. They could be tourists trying to find points of interest, or technicians trying to locate an address. Or they may want to search for features from within their ArcGIS services. Your app could use one or both of these. And first, let's look at searching for places. Searching for places is done using either an online geocoder service or a local locator file on disk. You can perform geocoding, which is getting a location from an address, or reverse geocoding, which is getting an address from a location. Let's look at geocoding. Geocoding in the SDK is exposed through an AGS locator task. You first need to initialize the locator task using either an online geocoder service or a local locator. Next, you can set a bunch of input parameters. This code snippet, for instance, sets a preferred search location by which results that are 50 kilometers from this location are boosted up in rank. You can also limit the maximum results the geocoder returns, and you can also eliminate the ones that are ranked lower by setting a minimum match score. Next, you would execute the geocoder with the search text, which is the address. Geocoding is an async operation, and it returns you a bunch of geocode result objects from which you can construct graphics and maybe display them on the map. So this is the basic workflow. You initialize the geocoder, set parameters, execute it, and handle results. However, in many cases, users might want to see suggestions as they type in the search text field. The SDK supports this workflow also. So for this, you first need to define some suggest parameters like categories or search area where to suggest. Then you would execute the suggest operation as the user is typing in the text field. Note that the results of suggest are different from geocoding results. So when the user actually picks a suggestion from the list, you would need to call geocoding with the chosen suggestion and get the geocoding results. With that, let's see a quick demo of geocoding. I'm going to be using the same app that Divesh showed. Let's go to the search category and pick the first one, which is find address. This geocoder uses, this sample uses Esri's world geocoder and allows me to perform searches in a number of different formats. I can say look up a country, like I need internet connection because I'm using the online geocoder.
Yeah, should have internet connection. The Wi-Fi is on?
It was on. Okay. Let's see if this works now.
Let's go back and come back in.
Yeah.
Opens.
Okay. I can also search for cities like New Delhi. The geocoder, of course, allows me to search for addresses as well. So that's Esri headquarters in Redlands. I don't have to know an address. I can just even type a point of interest, like the Taj Mahal. So that's geocoding. Let's look at another sample now, which provides suggestion as the user types. Let's say I want to find Starbucks close to our current location. So I start typing, and the suggest operation executes and provides me with a list of suggestions, first of which is Starbucks. And I don't think this sample uses a category or the search area like I showed. That's why it's showing such suggestions from all over the place. But let's just pick Starbucks, which is the relevant one, and search. So now geocoder executes and brings me the Starbucks closer to us. So that's geocoding. If Divesh could switch back to...
Question, can I
Yeah.
You talked about a local thing, an offline, so can I set my own data set?
Yes,
Okay.
you can.
So is there notes on the format for that somewhere?
It would be of the format .loc, and you can create that using our desktop applications like ArcMap or Pro.
And then it's just a latitude and longitude and a description or something, is it? Say I wanted an address like this room, Mesquite C, right?
Right.
I can add Mesquite C and put...
It's all driven by the attributes of the data that are used in your locator. So depending on what type of locator you have, it'll be driven based on that.
So that's done on desktop ArcGIS.
Yes.
Yeah, and it could be at different levels. It could be at the world level like I have, or it could be just specific to your region or city, right?
Okay, and then I can have that in an offline map package or on a web resource or something.
You can, yeah, and in a mobile map package as well.
Okay.
Yeah.
Suggest places, is it available offline as well?
Yes.
Yeah.
Suggest operations are available offline.
So let's switch back to the slides now. 5. So similar to the locator task we just saw for geocoding, there are other tasks in runtime that fit into the same pattern. So the general pattern would be you would construct the task and load it. It could either be from an online service or a local file. You would set a bunch of input parameters. You would execute the tasks, which is mostly an async operation, and you get the results back like we did with the locator task. Sometimes you get a job back, in which case you would listen. Jobs are basically async operations that run on server, and they are generally longer running. So you would wait for the job to complete before getting the results. We would take a closer look at jobs more in the upcoming sections. So with that, let's move on and talk about searching for features now. You can do this in a couple of ways. You may want to find features from a specific feature table, which is querying, or you may want to find all features at a specific map point, which is identifying. First is querying. Query operations are executed on the feature table, and the operation itself can either be online or local, depending on the nature of its backing feature table, whether it's a service feature table, in which case it's online, or if it's a geodatabase feature table, it's offline. And it also depends on whether or not the features are already cached locally. Query operation requires query parameters. You can search for specific features by passing in object IDs. Your query parameters could be attribute based, or you can also specify spatial query parameters that take in a geometry and a spatial relationship. Next, you would execute the query on the feature table with the query parameters. Query result has a feature enumerator which can be iterated over to get the result features. Next is identifying features. Divesh talked about it a little bit. Basically, identify allows you to discover features at a given map location. You can explore features from a given layer or all layers in your map. Similarly, if you have graphics added to overlays, you can explore those as well. The results of identify operation contain the features or graphics at that particular given location. So let's really quickly see a couple of demos. For that, so first for querying, let me go into features and feature layer query. So here I have a map showing the states of United States, and let me search for a state like Maine. So what happens is a query parameter based on an attribute from this service is created. So one of the attributes here is state name. So that query parameter is used to execute the query operation, and the results are then selected and highlighted on the map. And I think we also have an identify layers sample. So this sample shows it's a very simple sample. It just shows how many features are there at a given map location. Let's just tap on a point, and it gives me the count. And if I tap on a point where my layers intersect, I get results from both the layers from one single operation. So that's identify. And with that, I will pass it on to Divesh for analysis.
Thanks, Suganya. So let's briefly talk about analysis that you can do in your application. One of the most common one is doing analysis on transportation networks, things like finding routes. Currently, we have a route task available in the SDK, but in the next release of the SDKs, we'll add closest facility and service area tasks to help you find those things as well. Currently with the route task, you can compute point-to-point or multi-point routes, and you can optimize your route based on the distance traveled or the time taken. You can even ask for it to reorder stops to find the best sequence to optimize those criteria, and you can specify advanced restrictions like time windows and barriers to customize the route. And the route task works with the online route service that's hosted on ArcGIS Online, provides traffic data for 100+ countries, and it requires subscription, so it's going to consume credits. You need to be aware of that. If you have your own route service running on your on-premise portals or services, the route task can work with that as well. And many times you might have your own custom data, for instance, private road networks that are not part of the public domain, so you might have your own route service. If you want to do routing offline, the runtime supports that too through the use of mobile map packages, so you can package your transportation network along with your map, and then you can use the route task against the map package. I won't get into too much detail of how to do that. There's a whole section or whole session. There was a whole session yesterday that talked about building a routing application. So for those of you who have a time machine, you can go back and see it.
Is that in the SDK?
No, not yet. For other mere mortals like us, we can watch it on the website when they put the recordings up in a couple of weeks. The other type of analysis that you might want to do is use a geoprocessing tool or a service. And geoprocessing tasks is very versatile because the type of analysis you do really depends upon the type of service you have and the type of tools and models it uses. You can use a whole variety of online services that help you summarize data and find patterns. But you can create your own models to predict the path of wildfires, for example, or find hotspots and crime locations. And just a note about the geoprocessing task is some of these computations require a lot of time on the server, and that's where this concept of jobs come in. Tasks are single one-shot operation. You perform it, you get a result in a few seconds, and it's done. But with jobs, it could run for a longer period of time, so the client is required to poll the job to see its status on the server, and then when it's done, invoke its completion handler. So we model these differently in the SDK. If something's long running, it's a job. For instance, geoprocessing is a job. Downloading data from a tile service or a feature service is a job because it could take time. And you'll find it based on the hierarchy of the classes you're working with. So apart from spatial analysis, you can also do very simplistic geometric operations using runtime. There's a high-performance native geometry engine that's implemented completely locally. So you don't need access to any service, and it's incredibly fast. And you can perform simple topological operations like simplifying geometries, densifying them, or buffering them. Or you can find relationships between geometries, like which ones intersect or which ones overlap. And you can even measure areas and distances using the geometry engine. It's very powerful. And speaking of geometry, just another new pattern that I want to point out with the latest SDK is that geometries are immutable. So things like point, multi-point, envelope, polyline, polygon, once they're created, they cannot be modified. And this is done so that these objects are thread safe, which leads to a lot of performance in the core runtime, where we can guarantee that things won't change, so we can cache them. But if you want to modify geometries, we provide a separate paradigm known as builders, where we have geometry builders for each type of geometry, and you create a geometry builder. Either if you want to start from scratch, you create an empty geometry builder, or if you want to modify an existing geometry, you pass in that geometry to the builder, and then the builder's got methods to help you add vertices, remove vertices. And over time, it'll allow you to work with curves as well. And when you're done, you can tell the builder to give you the final geometry, and you'll get it. So just something worth mentioning. And to give you an example of that, let me go ahead and launch the Mac OS sample. So similar to the iOS sample viewer, we have a Mac sample viewer. It's on GitHub already, so you can download and build it, but we're in the process of adding it to the App Store. So you can get it from there in a few weeks. Here's an example of a sample that uses a geoprocessing service to find hotspots in 911 calls. So I can go ahead and hit apply, and I should get back a heat map showing where 911 calls were more common in this area. There you can see the red areas where there were more calls. An example of another geoprocessing sample is this one that helps me find view sheds. So if I click on the map, it's going to try and find all the areas on this map which are visible from that location, taking into account the topography. And those areas are highlighted here in orange. And using geoprocessing is really simple. You create a geoprocessing task with a URL to the service. So this is the service we're using with the sample. And then you create some geoprocessing parameters. On the task, you ask to get the geoprocessing job, and you start the job with a status handler and a completion handler. The status handler gets updated every time it polls a service to see what the status of the job is, and when it's finally done, the completion handler gets called with the results. So that's some example of geoprocessing. We have a geometry sample that shows the different spatial operations you can perform. So if I have two geometries like this, I can find the union, which is highlighted in red, or the difference, or the intersection. And we have some route and navigation samples as well. with that, I will switch it back to Suganya to talk about editing briefly.
Yes. Okay. Okay, next let's talk about editing using iOS and macOS SDKs. Just like querying, editing features is also done on the feature table, either a service feature table in case of online workflows or a geodatabase feature table in case of offline workflows. But geodatabases can also be present in local runtime content like mobile map packages that are created from desktop applications. Currently, we do not support editing them. So in order to edit geodatabases, they need to be downloaded from a feature service using a sync task. So with that, let me quickly talk about the sync task. In a general user workflow, the first step would be to create a sync task using a sync-enabled feature service. You can specify parameters like the layers you want to include in your geodatabase, the area of interest, whether or not you want attachments, so on. Then you download the geodatabase from the server using the generate geodatabase job. And when the job is complete, you get the geodatabase and you can access the feature tables in it. You can edit the tables. And when it is time to sync changes with the server, you use another job called sync geodatabase job. Sometimes in a data collection workflow, a geodatabase is downloaded once using the generate geodatabase job, but copies of it are given and put into different users' devices. In such cases, each of the copies have to be registered with the original feature service the first geodatabase was created with. This way, the edits in the tables can be synced with the correct service. So that was sync task. But when it comes to actual editing workflows, it doesn't really matter whether your users are in online or disconnected mode. The methods are the same. So first, add operation. The text in bold represents the classes, and the text underneath them are the actual operations performed on those classes. So to add, a new feature is created on the table, and attributes, geometry, and attachments can be then set on the feature. This code snippet, for example, shows an overload of the create feature, which takes in some attributes and geometry. So this creation process is all done in memory, and you need to add the feature to the table in order to commit it. For update operation, you first need to get hold of the feature either by query or identify. Then you would update the attributes, geometry, attachments, then call update feature on the table to actually update it. Deleting is simpler in that you get hold of the feature and simply delete it on the table. So with all these operations being common between online and offline, the difference between them comes when you want to send local edits to the server. In online mode, the local edits are applied through an apply edits method. And in offline mode, as I discussed earlier, local changes are synced to the service through the sync job. And updates on the server can also be optionally brought down at this stage. So that's editing. But you would notice that all this, I've just shown code. The SDK also provides other classes and tools that can help you with interactive editing. Let's quickly look at a couple of them. The first one is a sketch editor. Divesh already showed a demo of it. So it basically allows your users to create and edit geometries as you go. So to use it, you initialize it, you set it to the map view, and for new geometries, you can give it a creation mode, which can be any of the geometry types or even freehand sketching. And for existing geometry, you give the existing features geometry to it. And you simply stop when you're done. Sketching, as I said, supports freehand sketching. You can move the entire geometry. It supports undo redo operation. You can customize the symbols of the default sketch editor. You can choose to receive notification whenever the sketch changes, and so on. The SDK also provides a default pop-ups. Pop-ups are UI components that are used to edit feature information, which can be attributes or attachments. And you can edit geometry by linking the pop-up to a valid sketch editor. And pop-up enforces data validation and platform capabilities of the service, like ownership-based access control, etc. And the pop-up has a number of delegate methods for just about all events. When the editing starts, when the user cancels editing, when they are done, and so on. You can also customize the pop-up's appearance in a number of different ways. And pop-ups are a big topic by themselves. In fact, we have a demo theater on them this afternoon. Do stop by. And we also have another runtime tech session on editing your data online and offline, and that is tomorrow. I encourage you to attend them, and with that, I'll pass it on to Divesh now.
Okay, and we are mostly out of time, so I just want to point you to some of the other sessions that are coming. There's a couple of sessions for runtime that are common, like the road ahead, where they'll talk about some of the new capabilities coming in the next release. And the other sessions on Friday, where you can ask any questions you have about the runtime. It's an open forum. And then Suganya mentioned we have a session or a demo theater on pop-ups. We have another demo theater talking about authentication and securely accessing your data using in iOS apps. So check these out. Also, I want to remind you to, take our survey. Let us know how we did and what type of content you'd like to see next time. With that, I'll just open it up for questions.
Yeah.
Has anyone tried implementing the SDK with something like React Native? Something outside of
This question is, has anybody tried implementing the SDK with React Native? I think somebody with a strong stomach tried that a year ago. It didn't get too far. My understanding was they needed some bridging headers to be created for a lot of the SDK classes to make them available in the React environment. But that was the end of their excursion. So no, I can't say that. I can't speak intelligently about that. Question.
Does the runtime support any kind of real-time data, like stream service or stream layer, apart from adding like that and
Question is, does the runtime support real-time data through stream layers or stream services? No, we don't currently support it. It's on our roadmap to support. Question?
When someone's out with the application and an event occurs or something, how does that information get shared with the rest of the organization? So like for example, I'm going to verify something, I get out onto the road and I go to a location and there's an issue when I take a photo. And I'd like to send information back. Who does this communication fit in with your architecture?
So you're saying, how do we communicate information from the field back to the organization?
Yes.
If this is geographic information that you're collecting and you want to communicate, the simplest way is to use our APIs to edit the map data and add them as features in the service.
Modify the feature data itself.
Correct. Correct.
When you modify the feature data, it is communicated.
Correct. Yeah.
Okay. Unless it's offline.
Right.
Unless you're offline, yeah.
All right. That works.
sync cast, is it only supporting the user database or support other format as well, like SQLite?
It does use a SQLite in the backend. So the geodatabase you get back is a SQLite. Yeah.
Question?
Is it possible to package the geodatabase
You can include geodatabases in mobile map packages as well. Yeah.
But you can't edit them once they're in a mobile map package.
Not yet.
Yeah.
That brings up another question. When there is editing, is there any advantages between using a sync task and the Git geodatabase job versus using map packages? And what are the pros and cons? Wouldn't you be able to do both things? Do what you want regardless of which method you use?
So currently, I mean, the advantage of using the sync job is that you can edit that data and synchronize changes back to the server and get more changes from the server into the client. So you can keep the client data in sync with the server. With the mobile map package workflow, that sort of falls apart, because once you create the package, that's the state of it. If your data in the backend changes, you now need to find ways to create a new mobile map package and send it back. So mobile map package is an end state at this point. Whereas with the sync workflow, it's a continuous state where you can keep the client and server in sync.
Well, but didn't you say you're going to be able to edit data in a map package? How would you get those edits back?
We said
No,
you cannot edit.
Oh, I thought you were saying that's coming. All right.
Yes.
Does the 3D, or will it support both local scenes and global scenes?
Will it support both local scenes and global scenes? By local, you mean a small fish tank sort of an area? Yeah, yes, it supports both.
Do you have a runtime for that?
With the next few months, I think, when we release the next update.
Is the beta public? Or
Yes, so if you download the current release of iOS SDK, it has some APIs in there, some classes which are marked beta, and so you can use them, but then you can't deploy an app that's using those APIs. And
there's no separate beta version?
there's no separate download for the beta, it's part of that SDK. And the Mac SDK has those same APIs in Final, so you should be able to do that on the Mac already.
It's documented which ones you can't release, right?
Yes, each class mentions whether it's in beta or not. Yeah.
Did you say mobile map app packages, will they have editing down the line? Is it on your roadmap?
That's something we're thinking about.
Okay.
That brings with it challenges where then we have to make sure that the data that's in the map package came from a service, because if you make an edit, you need to be able to send it back to the service. And sometimes you can create map packages with data sitting on your disk, not coming from a service. So we haven't figured all of that out, so I want to say it's a distant goal, not an immediate goal.
But something that is coming up is taking your entire map offline. That would be coming up in the next few months. So if you have a map with a base map and a bunch of operational layers, you could technically download the whole thing as an offline map.
All right, thanks so much, guys.
All right. Thank you.